On section 7.2, we're going to try to do 3 examples on this one since they're not very long. So the idea here, this is the method of substitution for finding antiderivatives. What we want to do is just typically we're going to make our substitution the thing that's in the parentheses here. So, and typically the letter that we use is u. So if I let u equal 4x squared plus 8, what we have to notice is that the derivative of that du dx is equal to 8x. And then what we can further do is treat this as if it's a variable, this dx, and so we can get du is equal to 8x dx. Okay, so what that means is that when I see 8x dx, here's the 8x, here's the dx, notice what's going to happen here. What is going to become of that? 8x dx is going to turn into du in our integral. The rest of this, so this is du, what's the rest of it? That is u. Okay? So what we have, we're going to have a new integral here with this substitution. That's going to be the u, and it's the 6th power, so we're going to have a u to the 6th power, and then this all turns into du, so everything is taken care of. And notice we have a much simpler integral now. So that's just 1/7 u to the 7th power using the power rule. And then we can change that back into what u was in the first place. So we get 4x squared plus 8 to the 7th power plus a constant. Okay, for the second example, pretty similar idea here. Got x to the 3rd times the square root of 3x to the 4th plus 10. So here, again, the idea is usually what we're going to make our substitution is the thing that is in the parentheses, or in this case under the radical. So we can make that 3x to the 4th power plus 10. And then notice I'll just skip the du dx and just go straight to saying that du is equal to 12x dx. Okay? 12x to the 3rd, sorry. 12x to the 3rd dx. Okay? Now what I have to notice here is that I see an x to the 3rd dx, and that's the rest of the integral. I've already taken care of that with the u. But the rest of the integral, I've got x to the 3rd dx. Well, here's an x to the 3rd dx, but I've got a 12 here. And that 12 is not here, so I can fix that by dividing both sides by 12. So I get 1/12 du is equal to x to the 3rd dx. So again, what is this telling us? In our original integral here, in fact, in this case, I'm going to go ahead and start using different colors on this so that we can see a little bit better. So again, notice here, I don't know if that's much of a different color, but anyway. And here, what do these two things become? Together, x to the 3rd dx, what does it become? 1/12 du. So 1/12 du. And then for the rest of it, that's going to become just the square root of u. So let's see what we get out of this. So the 1/12, since it's a constant, I can pull it out in front of the integral. So I'll get 1/12. I'll wait for the du for the end. But whenever we have a radical, we always want to write that as a fractional power. So the thing that we made u was all of that under the radical. The fact that it's a square root means we can change it to a 1/2 power. So this is the integral that it turns into after this substitution. We can use the power rule on that. And so remember, we're going to raise that by 1, so we're going to get u to the 3/2 power, and then we multiply that by the reciprocal of the exponent. Okay, and then we'll combine our constants and we'll replace the u back with what it was. So the 2 and the 6 here can cancel, or the 2 and the 12 can cancel, giving us a 6 in the denominator multiplied by that 3. We get 1/18. U was 3x to the 4th plus 10. And then this is a 3/2 power. So there's our antiderivative for this thing. And just remember that you can always check your answers on these antiderivatives by just taking the derivative of your answer. What should happen when you take that derivative? You should get the thing that you started with here. So let's do the third example. Similar again. So this is 4x squared plus 8x to the 3rd power. Okay, so now, again, the idea almost always, particularly for this class, u is going to be the thing that's under the radical or within the parentheses or in the denominator. So in this case, what's in the parentheses? 4x squared plus 8x. And then the next step on all these substitutions, always find the derivative of that, just say du, and then we get 8x plus 8 dx. Okay, now notice what I see here is I've already taken care of the denominator. That's going to become u to the third power. But what's left? X plus 1 dx, okay? This is why it's important to never forget that dx on there. If I factor an 8 out of this thing, or actually maybe a little quicker, if I divide everything through by 8 on this thing, I'm going to get 1/8 du is equal to x plus 1. X plus 1 dx, okay? So what does that mean? That means when I see x plus 1 dx, well, there it is, x plus 1 dx, okay? X plus 1 dx turns into 1/8 du. So that means my integral is going to change. Any constants can always be put out front. So the 1/8 comes out in front. The x plus 1 dx all changes to du. So I'm basically just going to have du in the numerator, and then I've got the 1/8 out in the front. The denominator we said was, well, the thing in the parentheses is u. So this is the integral that it changes into. Now we can do this one also with the power rule, but we first have to write it as a power function, negative third power. Power rule says we're going to raise that by 1. So let's just do this the way we normally do. Raise this by 1, so we're going to get a minus 2 power, and then I also have to multiply by the reciprocal of that, so negative 1/2 plus our constant. Then multiply these together, I'm going to get negative 1/16. U was, in this case, 4x squared plus 8x. And this is to the negative 2 power. And if you want, you can write this without negative exponents as negative 1/16 times 4x squared plus 8x to the positive 2 power plus a constant. Okay? In my math lab, of course, it's not going to matter whether you leave the answer like this or you put it like this. Okay? So we'll continue this on the next video.